as part of the agenda, what we are going to do is we are going to understand the importance of Kubernetes. Okay, that's what the first thing we are going to understand, because you need to understand about the importance of Kubernetes. Then only you'll be understanding the EKS, and then only you'll be understanding the EKS auto mode, why we are using EKS auto mode and all those things. Okay, now we are just going to list out cloud implementation of Kubernetes services, like cloud uh, implementation of Kubernetes. That's the second thing that we are going to understand. And we are going to go to the intro to EKS, EKS, EKS. The next part is going to be the disadvantage of using the EKS cluster, disadvantage of provisioning of the EKS cluster or maintaining the EKS cluster without the EKS auto mode. That's what we are going to see. Disadvantage of provisioning or maintaining EKS cluster without auto mode. Okay, that's what the next point that we are going to discuss as part of the agenda. And we are going to see what are the problems that the EKS auto mode solves. Uh, Problems that EKS auto mode solves actually. Okay, that's what the next point that we are going to understand. I'm going to present you some diagram actually. So what is the difference between normal EKS cluster and the EKS cluster with the auto mode? What will be the difference between that the diagram presentation will be there? Okay, and the next part is going to be the practical session will be there at the end of the thing. Okay, practical. Okay, so that is the agenda. That is the agenda for today's session, guys. This is the agenda for today's session, and these are all the topics that we are going to discuss in the today's session. Okay, that's what it is. Are we good to go? Anyone have any questions on this, guys? Okay, if no questions, let's move further with this particular agenda, guys. Okay, see, Kubernetes and its importance. You need to understand that particular point first. Okay, Kubernetes is very important, guys. Suppose you have an applications, you are developer, or in your company there is a developer. That developer has developed an application. Let's say he is a developer who developed an application. This is a developer. Let's say this is a developer who developed an application, and this is the application that he has developed. Okay, and this application need to be deployed. This is an application and he is a developer, let's say, and it is an application. Okay, so this is the developer and he is application. It is an application, and this application need to be deployed on a server so that the users of that particular application can use that particular application and do the whatever it is. Let's say this is an e-commerce application, and the developer developed this e-commerce application, and once the developer developed an e-commerce application, that need to be deployed on a server. So this is server, like normal server. It is not a Kubernetes actually. So I'm talking about normally without Kubernetes. Let's say this is a server, and this on this server, this application need to be deployed, right? This application, the people need to place that application onto this server, right? Let's say the people place an application on this server. This is an e-commerce application. Okay, it's an e-commerce application. Okay, so then only the users who are using this application, like what you can do in the e-commerce application, you can purchase the products, right? Whatever the products that you have chosen. right? As part of the application, right? So that's what it is. You can just visit as a user. He's a user. Okay, let's say he is a user, and he will be visiting this uh, application from his browser, and he can purchase the products through that particular application. Okay, this is a normal setup without Kubernetes, how it is, how it looked like. The it is working as expected, and it is working in a good manner, and everything is fine as of now. But tomorrow there is a huge, the users who are accessing application is increased. Let's say he is a second user, like that. The users who are accessing this application has been increased, like, and the current server is unable to handle many number of requests that the users are accessing from to this application. So in this case, if you are deploying this particular application without any Kubernetes environment, okay, so the scaling, okay, see, whenever the huge number of requests that are accessing this application, the server is not capable amount of handle that many number of requests. If the server is not capable amount of is if the server is not capable of handling that many number of requests, you need to do the auto scaling. That means a new server you need to create like this, and you need to deploy the same application on that new server, so that now there are two servers in order to handle your application. And if even though there are huge number of requests, your application can handle that many number of requests actually. So this kind of functionality is required when there is huge number of requests are coming. Now suddenly tomorrow what happened, the users got decreased. Okay, let's say the users got decreased. Now in that case, if you have two servers to run your application, then you need to pay for two servers, right? Server 1 you need to pay, server 2 also you need to pay, right? So it is a not cost efficient solution. You need to pay for both. Even though there are very less number of requests, only one server can handle that many number of requests as of now, because the traffic has been decreased. Even though that is there, right? Even though that is there, you are handling two servers, and your application is deployed on two servers, and your application is serving the traffic within the two servers. Like, it is not a cost effective solution. What you have decided, you have decided to remove one server and run the application in one server only. So this is the scale in activity and scale out activity. That means whenever huge number of requests are coming, whenever huge number of requests are coming, you need to add one more server, and you need to deploy your application on that server. Whenever the request goes down, you need to downscale the server. So this activity is very tough when you are deploying the applications directly on the servers. Okay, scale in and scale out activity you can do definitely, but it is not that easy to do with normal deployment without Kubernetes. Okay, so like that, very disadvantages are there. Lot of disadvantages are there if you deploy the applications directly on a server without any Kubernetes environment. Now let's talk about the advantages. Let's say you have advantages, okay, of using Kubernetes. Okay, so the first advantage, it is very easy to scale in Kubernetes. Of course, you know it of scaling it automatically, that will scale. Okay, the people who have used the Kubernetes cluster might be knowing that, right? So automatically, if the traffic is there, automatically pods will be scaling. Automatically, the cluster nodes will be scaling. The servers will be scaled. You no need of doing that. It is the advantage. It's a beauty of Kubernetes actually. The scaling is very easy. Scaling is very easy in 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 using Kubernetes to deploy applications. That's the first thing. Very important, guys. Scaling, increasing the capacity of your application is very easy in deploying in using Kubernetes environment. That's what you need to understand in deploying your applications to the Kubernetes environment. Okay, that's what you need to first understand about it. The second thing is, suppose, let's say in the normal servers, if you deploy your application, let's go back to the normal servers, which is there in the diagram, right? If you deploy this application on a normal server, something like this, let's say your application got crashed. Your normal server is not responsible to restart your application. If the if you deploy your normal server, if you deploy your application on a normal server, now let's say your application is crashed, then your server is not responsible to restart your application. And in the normal server, if you deploy your application in the normal server, because of this reason, your server is not responsible to restart your application, right? Because of this reason, your application is not highly available. The high availability feature is missing if you deploy your application directly on the normal server. But in Kubernetes, if you are deploying your application on Kubernetes cluster, okay, if something happens to your application in the Kubernetes cluster, the people might be knowing, like whoever use the Kubernetes, the application will be automatically restarted. The application new pod will be automatically launched. You need of doing that anything manually. But in this case, a manual engineer is needed in order to restart your application and in order to see the what is happening. But in case of Kubernetes, you no need of doing that. Automatically Kubernetes platform is going to take care about that. Okay, that's another like advantage of using Kubernetes. Okay, so the second advantage is there will be high availability of your application. High availability of application in deploying it in Kubernetes environment. Guys, I'll address your questions definitely, but yeah, just give me some time. I'll complete this actually. Okay, that's the thing. Like, suppose this is a second advantage. Okay, now next advantage. Let's say your application is there and you have deployed your e-commerce application to the normal server. Okay, and this e-commerce application is perfectly running fine. Okay, this e-commerce application perfectly running fine, guys. Now let's say a new version of your application is released. Now you need to update the existing application which is running. Now that means you need to terminate the existing application and you need to replace it with new application. First, what you need to do, you have your developer updated the code and he has released a new application, new version of the application. That means if you want to make this new version of the application to be in the running state, you need to delete the existing version of the application and replace it with a new version of the application. That's what you need to understand. Now, if you delete the existing version of the application and if you want to replace it with the new version of the application, let's say you have deleted the existing version of the application. Let's say this is deleted to do it to release a new version of the application. Right now, you have deleted. And what about the incoming request now? Like people will be like always accessing your application, but your application you have deleted in order to make the update, in order to release the new version, in order to deploy the new version of the application. Okay, so like between the deletion and recreation of the new version of the application, if there are some requests, those requests are going to be affected if you deploy your application directly on the server. But in Kubernetes, you have some deployment strategies. The people who use the Kubernetes might be knowing, right? So you have some deployment strategies, something called rolling update. Okay, that feature of Kubernetes will make your applications to be uh, faster and safer, to be in safer deployments, because this is not a safer deployment, because if you delete the old version and before deploying your new version of your application, if someone requests are coming to your application, then they are going to be affected. But in case of Kubernetes, there is some features called rolling update, so that feature is going to be helping you with safer deployment. Actually, that's what you need to understand. So you know like rolling update rolling update feature will help us with safer deployment. Okay, like that. Okay, just understand that. Okay, like that, you have many advantages of using Kubernetes platform in order to deploy your applications, guys. Like this, if you keep on talking advantages of Kubernetes, it keep on coming, guys. Okay, that's what you need to understand. That is why the Kubernetes is very important, very important platform in order to deploy your application. Nowadays, everyone are expecting Kubernetes as a tool, as a knowledge that you that the engineer should require in order to have, so in order to manage the Kubernetes clusters. Okay, that's what the advantage of Kubernetes, guys, when we compare to the normal server deployments. Okay, if you keep on talking, like, let's stick to these advantages, but if you keep on talking, Kubernetes advantages keep on coming, guys. Okay, it deals with security, it deals with networking, very will be very easy, multiple things are there with Kubernetes. Okay, that's what you need to understand. Okay, now, like, Kubernetes is a platform. Okay, Kubernetes is a platform where you can deploy your applications. Okay, that's what you need to understand. Let me put that point as well. Just note, as a note, let me put it actually. Kubernetes is a platform to deploy our applications. Okay, as Kubernetes is a platform to deploy our applications, the cloud providers in market, like what are the cloud providers that we have in the market? We have a lot of cloud providers in the market, correct? AWS is a one cloud provider, Azure is a cloud provider, Google Cloud is a one cloud provider, DigitalOcean is a cloud provider. Like, these are the, like, multiple cloud providers are there, but like mainly like famous ones are Azure, AWS, and Google Cloud, right? So the cloud providers released Kubernetes as a service, released a platform in that particular accounts. In, if you take AWS has released some service within itself, that is something called AWS EKS, Kubernetes as a service. Okay, they are like how in clouds, how EC2 as a service. Okay, how you are using S3 as a service, how you are using CloudFront as a service, like that. AWS provided EKS as a service, guys. Okay, where you can create a Kubernetes clusters. Like, they have provided you a service, and within which you can create a Kubernetes cluster, and then you can deploy your application there. Like that, Azure has provided that something called AKS. Okay, and Google Cloud has provided a service called GKE, Cloud Provider Clusters. The cloud provided clusters, actually. You just let me put it here. So, cloud providers implemented Kubernetes and provided us as a service. Okay, that's what you need to understand. If you talk about AWS provided something called AWS EKS. AWS, let me just put the service name EKS. That is and if you talk about Azure, and if you talk about Azure, it is AKS. And if you talk about GCP, Google Cloud Platform, that is GKE, right? So these cloud providers have provided some release the Kubernetes platform as a service to us, and we can create the clusters as part of that particular services. Okay, okay, so these are the cloud provider Kubernetes clusters, guys. Okay, that's what you need to understand further. That's the thing. Okay, before moving further, if someone is new to the Kubernetes, let me clear some things, actually, some things. Okay, so what is Kubernetes cluster? That's what you need to understand. We have understood what's the importance of Kubernetes, and we have understood like what are the problems that it solves actually, and we have understood what are the clouds and the services that they provide, like AWS provide EKS, Azure provide AKS, GCP provide GKE, right? Now let's understand what is Kubernetes. Like Kubernetes is a platform, that's what I have told you. Like how that is look like. Let's say if you put that Kubernetes as part of the diagram, it will be something like this. We'll be talking about something called some Kubernetes terminologies. If some, like, I hope most of you people know, but let me put that points if anyone are there new to the Kubernetes. Let's say we mainly talk about the cluster. What is cluster actually? That's what you need to understand. The second thing is you need to understand what is node. Okay, and you need to understand what is pod. These are the three terms that we are going to understand as a prerequisite before moving to our actual things. What is a cluster? Cluster is a combination of multiple nodes. Kubernetes cluster. Instead of saying cluster, let me take Kubernetes cluster, guys. Okay, just let me put Kubernetes cluster. Okay, cluster. Come on. Okay, and Kubernetes node, and we need to have Kubernetes pod. Just pod. Okay, just understand. We'll understand that. That's it. Cluster is a combination of multiple nodes. Let's say you have a cluster. This is a cluster, let's say. This cluster contains set of nodes. Set of nodes grouped together is nothing but a cluster. Okay. Set of nodes grouped together is nothing but a cluster, guys. Okay. This is first node in the cluster. And like, what is this nodes actually? I'll tell you what is this nodes. Nodes means servers, guys. Servers. Set of servers grouped together is known as a cluster. This is the cluster. This is the cluster. Kubernetes cluster. Okay, just let me put that one label there. Okay, and this is the nodes in the cluster. Node 1. Okay, just I'm placing node 1, node 2, and node 3. Okay, a set of nodes, combined together, we call it as a cluster. And nodes means server. Each node is an individual server. Okay, a set of server. You can also say a set of servers combined together is called a cluster. Okay, that's what it is. And what is pod? Pod, whatever the application the developer developed, that application you will be deploying as a pod in the Kubernetes cluster. It's a smallest unit in Kubernetes that we call VTC. But yeah, pod is a smallest unit in Kubernetes with which we are going to deploy our application to the Kubernetes cluster nodes. That's what it is. Okay, that's what the three terms, guys. Pods, nodes, pods, nodes, cluster. Okay, that's what you need to understand from the point. Okay, now just that's the thing, guys. Okay, now let's just, as of now, everyone clear, guys? Is that clear for everyone? Is that clear one? Clear everyone? Pod means like you can deploy your application as a pod to the Kubernetes cluster. The application will be deployed as a pod. It's just a term that we use in Kubernetes. That's what you need to understand. Okay, yeah. Inside the pod, your application will be there. Inside the pod, a container will be there. Inside that application will be there. All these things will be detail explain. Like we will be explaining in detail as part of our course. But yeah, as this is a demo, like these are some of the things actually. That's what you need to understand. Node group. I'll talk about that, Amir. We'll talk about that. Okay. So in case of EKS, we have something called node group. I will talk about that. No issues. From the term itself, you need to understand. Okay. What is node group, guys? Okay. Let me take a new thing, new paint. Okay, so let's say you have EKS cluster, and in this EKS cluster, this is a Kubernetes. EKS means like it's Kubernetes cluster. Kubernetes cluster. Okay, and in this you can group a set of nodes. Let's say this is one group and this is the another group in the cluster. And in these groups, we can have servers that are nodes. Okay, so this is something called node group, guys. Okay, so we have a cluster. In that we have two groups. They are the node groups. Inside that we have a servers. Okay, the, these are the servers. These are the nodes. Nodes and servers both are same. That's what you need to understand. Okay, cluster, node groups, group of like we'll be like we'll be grouping nodes together, like set of nodes together in EKS cluster. That is something called node group. A group of nodes together called as node group in EKS cluster. That's what you need to understand. I hope it's clear, right? I've talked about that, Shrikant. Just before this one, you can see advantage of using Kubernetes. Just I have talked about that in the initial time of our session. Okay, so now let's talk about the disadvantage of directly using the EKS without the auto mode. Okay, so let me put that points here. Okay, the disadvantage of using EKS, creating creating or maintaining the EKS cluster without the auto mode. Without the auto mode, that's what we are going to talk. The next point is that, okay, uh disadvantages of using provisioning, using or maintaining disadvantage of provisioning, using or maintaining EKS cluster without auto mode. That's what the next point. Okay, let me put that one here. Okay, let's say the AWS has not released the EKS auto mode feature, and there is a just EKS cluster you want to create. Suppose similar thing. Let's say the same application is there, the developer is there, the developer is there. This is a developer who is there. Let's say he's a developer and he has developed the application in whatever the programming language. He can choose Java, you can choose .NET, you can choose Python. What is the programming language? He know that he developed an application, that is this one. It's a uh, application. Let's say it is developed in Java. Okay, so this is an application that is developed. And let me label that as well, developer, and this is an application. That's an application. That's what you need to understand from the point. Right. Now, he understood, developer understood, okay, the disadvantages of using normal server over Kubernetes. And he understood the importance of like Kubernetes platform if the application is developed on the deployed on the Kubernetes platform. And the people in the organization decided now to deploy this application on a Kubernetes platform. So the people in the organization, let's say these people in the organization or the company, people in organization decided to deploy application to Kubernetes cluster. Okay, because they face some issues if they deploy the application on a normal server. So they understood the importance of Kubernetes and they want to deploy now the application to the Kubernetes server. That's a decision that the organization taken, and they want to deploy that application to the Kubernetes cluster. Okay, now that decision is complete. The decision is taken, like the organization has taken, the team leads on the managers sitting together, meet, they have one meeting, and they decided to deploy this application on the Kubernetes cluster. And they have choose the AWS EKS service in order to create a cluster. Okay, while creating a EKS like they want to create it, like they want to deploy their application, that is this one. As they have decided to deploy the application on Kubernetes platform, they want to deploy that application as a in the EKS cluster, in the AWS environment that they have decided. Okay, they have decided to use Kubernetes, and they want to use as Kubernetes, as EKS is the implementation of Kubernetes. They want to use EKS platform to deploy application. That's what you need to understand. Okay, they just they just taken the decision. They just took the decision, actually. That's what you need to understand. Now, people, the managers have contacted the DevOps people, actually, because the DevOps is the one who is going to manage the Kubernetes and all those things, but the developers also nowadays. But yeah, understand, the DevOps people want to create a cluster and they want to deploy the application to the cluster, but they don't know what size of the cluster need to be created. Like how many, like in the cluster, how many servers need to be there. They don't know initially, because like because whenever they create a cluster, they should know that how many number of size instance, like they don't know, because they are very new to the Kubernetes, as well as they don't know how many number of requests can come today or tomorrow, and they are very new. And let's say that is there, actually, we are not sure. The first disadvantage of initially, we want to create a Kubernetes in order to deploy this application to the Kubernetes cluster, right? So if you want to deploy this application to the Kubernetes cluster, DevOps people comes into picture. So as a Kubernetes administrators, DevOps maintains the Kubernetes clusters. As a Kubernetes administrators, they will not be initially knowing. Definitely, it's a hard decision to take, how many number of nodes to be there in the Kubernetes cluster. Very hard decision. Okay, that's a first disadvantage. We don't know initially. That's a first disadvantage of directly provisioning the EKS cluster, directly creating the EKS cluster without the auto mode. We are not sure. The first disadvantage is we are not sure how many number of instances, how many number of servers, servers, or we call it as nodes in the Kubernetes, are sh- should be there in Kubernetes. Okay, we are not sure how many number of servers or nodes should be there in Kubernetes while creating initially. Okay, that's a first and foremost disadvantage, guys. Okay, that's a first and foremost disadvantage. We are not sure how many number of nodes should be there in the Kubernetes, because they have, the managers just take a decision, that's it. They will leave to the team members, like who are managing the Kubernetes cluster, or the leads. Okay, so initially people will not be able to know how many number of nodes should be there as part of the Kubernetes, guys. That's what the first disadvantage of using normal EKS cluster. Okay, that's what it is. The second thing is, we are also not sure, as a DevOps engineer, we are also not sure with what instance type. Like servers has server types, actually. Okay, now if you just go to the Chrome and search for the server types, instance types, just search for instance types. Amazon EC2 instance means server types. There are lots and lots of instance types, guys. Where are they? One second. Let me go here. Come on. Yeah, here it should be. Say storage optimized computer. Let me take the computer optimized. These are the instance types. You can see that here instance size and like C8G dot medium instance type actually. Okay, C8G dot large. There are lots and lots of instance types that AWS provides to us. Okay, like what will be the difference between the instance type? If you take C8G dot medium, instance means server, node instance, server, both, like everything is same, everything is server only. If you take C8G dot medium, that has one CPU and 2 GB memory, and C8G dot large, that has 2 CPU and 4 GB memory. Based on the instance type, your servers will be provisioned. Like if you are provisioning, if you are creating a server with C8G dot large, that server will be having two CPUs and 4 GB memory, like that, 4 GB RAM or memory. Okay, now initially while creating the Kubernetes cluster, we are not sure what instance type that I need to choose actually. Okay, we are not sure what what instance, what server type, okay, that we need to choose, for the nodes in Kubernetes cluster. That's what the second disadvantage. Okay, like if you are creating a EKS cluster without EKS auto mode, you need to create lots and lots of resources. Creation of Kubernetes cluster is not that easy. You need to create VPC, you need to create subnets, you need to create route tables, you need to create IAM roles, you need to create NAT gateway, internet gateway, multiple things that you need to create, right? So lots and lots of things that you need to create, guys. Okay, but that's what the other disadvantage of using the EKS cluster without auto mode. Manual creation of resources. Manual creation of resources. Okay, that's what the next thing. Okay, and the next thing is you can also create that through Terraform as well. But through Terraform, if you are creating through Terraform, right? Then also you need to write the code for all the resources. Okay, so if we are creating from Terraform, then also we need to write the code for the resources actually. Okay, then also we need to write the code for the resources. Okay, that's what you need to understand. Now the next disadvantage, if you are using EKS cluster without the auto mode, scaling of nodes. Scaling means if the like here we have seen the example here. Where is that previous example? Where is the previous? Yeah, here it is. Like if the high number of requests are coming, right? So you need to add manual server in the manual case, and you need to deploy the application. All those things will be there in the manually. But in case of EKS, you need to deploy something called autoscaler, horizontal pod autoscaler, or EKS autoscaler, something like that. It's a plugin that you need to deploy to the Kubernetes cluster. Then your cluster nodes, cluster servers will be scaled. The scaling is easier when we compare to manually deploying the applications on the servers. In Kubernetes, scaling is easy in Kubernetes, but yeah, EKS auto mode makes it very simple than this normal EKS scaling actually. That's what it is. Scaling is a bit uh, tough, or you need to manage something called autoscaler kind of things. It's a plugins that you need to install to the Kubernetes, so that the scaling will be happened automatically. You will be seeing this practically, but yeah, that's the thing. Uh, But in case of automotive, it is not going to be like that. Just automatically scaling will happen. You know of managing anything. Scaling is bit tough in normal EKS, EKS cluster. Okay, but when we compare normal EKS cluster with a normal server deployment, then the normal EKS cluster is very easy. That's what you need to understand. But when we compare EKS cluster with the scaling in EKS cluster with the EKS auto mode, then auto mode is very easy. That's what you need to understand from the point. Okay, that's what you need to understand. Security. Security patches. Suppose if you want to apply some security patches to the servers, you need to do that manually in AWS EKS. But in case of EKS auto mode, you know of doing anything automatically, security patches will be applied within 21 days of the node creation. Okay, the security patches, it's very tough. Like it's manual. Let me take, we are responsible, we are responsible for applying security patches in using AWS EKS, normal AWS EKS. That's what it is. Okay. That's the next disadvantage. The upgrades. You need to do manual upgrades if you are not using AWS Auto Mode. We are responsible to do manual upgrade and manual EKS cluster upgrade. Like if you want to upgrade the cluster version from 1.31 to 1.32, then you need to do manually from the console or through from the Terraform. Okay, you are responsible to do manual EKS cluster upgrades actually. But in case of auto mode, it is not going to, it is automated actually. Okay, so now this like this will, there are lots and lots of disadvantages. There is a disadvantage of with respect to cost. Let's say initially you don't know the number of servers you want to provision, right? You can see that here we are not sure how many number of servers or nodes should be there in the Kubernetes cluster while creating the cluster, while creating initially. Actually, that's what the first point, right? So if you don't know how many number of nodes are required within the cluster, and you have guessed one number, let's say I have guessed some five, and I have created a 5 node cluster, 5 server cluster. So if the 5 servers are not getting used, right, so that means I am over provisioning the cluster even though they are not used. The server is keep on running, the server is keep on running actually. So that means I'm over provisioning the cluster. If I am over provisioning the cluster, the cost for the cluster will be more. Okay, so the next disadvantage in using the EKS cluster without the auto mode is the cost management is high. Okay, that's what you need to understand. Like this, if you keep on talking, EKS auto mode provides lots of like advantages when compared to this actually. Now these are all the things that will be solved by the EKS auto mode, guys. All these advantages that you are looking here, okay, all these disadvantages that you are looking here, all these problems are solved by EKS auto mode. In EKS auto mode, you no need of knowing how many number of nodes that the cluster should require initially. Automatically, whenever the cluster is like whenever the nodes are required, whenever the servers are required within the Kubernetes cluster, based on the pods that you are deployed, based on the application that you are deployed, automatically servers will be created. You know of creating before initially while creating the cluster. Okay, that's what you need to understand. First point is that advantage. Okay, and you know it of understanding what type of server need to be provisioned. Like I've told you, right? Like C8G.large, C8G.medium. Previously, I've shown you the instance type, right? You need of understanding that what type of instance type, what instance type to be used for creating the server in the cluster. You need of understanding that EKS auto mode is going to take care about that. What type of server need to be created. Okay, and you are not, the next point is what we have discussed is this one, right? You are not you are not creating any resources manually. You just click the button, then the cluster will be ready for you. Okay, that's what you need to understand. Manual creation in the EKS auto mode will not be there. Everything is ready for you and you can just deploy your application actually. Okay, that's what it is. And even though if you are creating from Terraform, it will be very easy for creating the EKS cluster using the auto mode. Okay, so in case of EKS, the scaling, you are not it's a beautiful feature, guys. It's very important, a beautiful feature. You need of uh, worrying about the scaling. Okay, it will be done automatically. Everything is done automatically. You are not going to do anything there. Okay, and we are not responsible to apply the security features in EKS auto mode. If you create a EKS cluster with auto mode, you no need of applying any security features. EKS auto mode is going to take care about the security patches. Okay, you need of applying manually. Generally, if you are using normal AWS EKS cluster in order to deploy your application, you are the one who is responsible to apply the security patches. But in case of AWS EKS auto mode, you no need of applying the security patches manually. It's AWS responsibility, it's EKS responsibility in order to apply the security patches. Okay, so it's a great feature, guys. Okay, we are not responsible to do any manual Kubernetes cluster upgrades in EKS auto mode. Automatically, whenever you send an API request to the EKS, the cluster will be updated automatically. You know, of doing anything actually. So as the cluster servers are scaling, whenever it is required, the cluster nodes are scaling, whenever it is required, then the cost will be very less for us, because whenever the application require the server, then only it is scaling. It is not scaling before within the cluster, right? It is not creating like generally, if you are not using the EKS auto mode, you need to create a server before, whether it is required, whether your application required the server or not. But in case of auto mode, if you just choose the creation of EKS with the auto mode, you know it of having the server prior. Okay, EKS auto mode automatically creates the server. As it automatically creates a server whenever it is required, the cost will be very less actually. So that's what you need to understand whenever you are using the EKS auto mode. So the disadvantages that we have in case of AWS EKS that are made into advantage in case of AWS EKS auto mode, guys. That's what you need to understand from the point. Let's now move to the console. Like, let me take the question before going to the practical. Anyone have any questions? I see some questions in the chat. Okay, let me address that questions before moving further. Okay, so that's what it is. So I have one question. If you are using AWS EKS and node running EC2 or node also running the EKS. See, EKS is a combination of multiple nodes. Yuvraj, nodes are not going to run EKS. Just EKS is just a platform. Just if you see the diagram, where is the diagram? This is the EKS cluster. Outer layer is the EKS cluster. Within the EKS cluster, the nodes will be there. That's what you need to understand. Okay, the EKS will not be running inside the nodes. EKS is just a name, a group of servers, a group of nodes is nothing but a cluster. That's it. Okay, so just you need to reframe your question. Okay, uh, yes, pod creation and node, everything is maintained by the EKS only. Yes, that is visible to EKS cluster, Yuvraj. Definitely that will be there. That is definitely visible to EKS cluster. Which is the container here? No, Sunil, it's a pod. Inside the pod, your container will be there, Sunil. Inside this pod, your container is going to be there. Inside this pod, your container is going to be there. Inside the container, your application is going to be running. That's what you need to understand. Okay. Yes. Uh, yes, Ame, it is correct. EKS cluster upgrades means moving cluster from one version to the another version. Yes, you are right. Okay, let's now move to the EKS auto mode case. Let me now move to the AWS account. If you just go to the AWS account, this is the AWS account that we have. Just you need to go to the, you need to search for EKS. Just search for EKS. You will be seeing EKS Elastic Kubernetes Service. Okay. Just if you see that I'm using the region called, I'm not going to use North Virginia. I'm going to use Ohio. Okay, so I'm going to use the region something called Ohio. This is a platform where we can create a EKS clusters, guys, in AWS. You just need to create a, just click on create a cluster. Now you can see that here, quick configuration with EKS auto mode. This is the first option that you can use with EKS auto mode. And you have a custom configuration as well. If you click on this, you need to do everything manually and all those things while creating the cluster. But if you are choosing the EKS auto mode, you no need of doing anything. Just you need to, if you want to change the name, you can change the name, UAT, like prod cluster, prod hyphen prod prod cluster. Okay, that's what it is. I want to just run the cluster version as 1.33, and just you need to create a IAM role. Just you need to follow the steps, create a recommended role. The role will be there. Just click on this one. That will auto populate the role that need to be created. Just you need to click on next, 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 and just your role will be created, and that role will be populated here. Okay, if you click on this refresh, that role will be coming here. In the same way, you need to create a role for this node. If you are doing for the first time, if you are creating the EKS cluster for the first time, these two steps that you need to do: EKS cluster role creation and node role creation. Okay, this is something called IAM role, and all other things you need of doing anything. Just you need to click on this quick configuration with EKS auto mode, and just let me click on create EKS. Just click on create. Your cluster will be ready for you within some minutes. Okay, so it is as simple as that. You no need of doing anything. You just click on create a cluster and just click on create. That's it. Okay, you no need of provisioning any VPC, any subnets, any route tables, any configuring them. Everything is not required. Everything is provisioned by the AWS EKS, AWS EKS only. It is as simple as that. Okay, now that's what you need to understand from the point. Okay, so now this is one thing. Okay, now let the cluster be created, guys. We will be moving further with our demo. Let the cluster be created. Okay, now I have some questions in the chat. Actually, let me take the questions. uh yeah, internally this uses the carpenter only. Okay, so if you are directly using the carpenter, again that will become the manual thing. Okay, but internally EKS automate is going to use the carpenter only. Okay, why I am not see in the EKS cluster and I seen in the node EC2? Why? I did not get your question, Yuraj. Can you reframe it? Dolly, can serverless Lambda deployed on EKS cluster? Is this a valid scenario? No, there are serverless. There is a serverless. Uh, uh, that means you are not going to maintain servers. Yes, EKS also provide the serverless Fargate profiles, we call it as. Okay, where you can have that if you go to the compute, and you can also create a servers, like you can also deploy your applications as a serverless like Lambda using these Fargate profiles. This will be everything about this node groups, Fargate profiles, everything will be taught as part of our normal sessions. But this is, as it is a demo, we are not going to go to the serverless kind of thing, Dolly, but that is serverless. Yes, you can also do that, but using the like Lambda, you can also do that, but using the Fargate profiles in AWS EKS. That's what you need to understand. Uh, I did not execute any YAML file, Yuvraj. Just I went to the screen, I went to the console, went to EKS cluster, just went to EKS service, I clicked on create a cluster and just scrolled down. I have scrolled down and just clicked on the create a cluster. That's it. I did not execute, no need of using anything. Just it will be automatically created. Yes, all these create automatically, Prasad. Okay, yes, you're right. Yeah, yes, Prasad. All those things will be created automatically. You no need of dealing with that anything. Okay, okay, that's what you need to understand. You're not doing without anything. Okay, I am also introducing you to the new tool that is something called EKS or like node viewer, with which we are going to view the nodes, scaling of the nodes. I'll deal with that. Node viewer, EKS node viewer. Okay, this is one of the tools that we are going to use in order to view the nodes. Okay, but yeah, let's see that. But before going that, I want to present you with the diagram. Okay, the next point is present the diagram. What will be the difference between our actual EKS and EKS with auto mode? What will the difference actually? Let me try to help you with the diagram. If you This is the diagram that is provided to us by AWS, but yeah, if I just present it, that will be good actually. And if you see, this is the diagram, guys. Left side, shared responsibility model with EKS auto mode, but in like shared responsibility model with EKS previously without the auto mode. If you check, shared responsibility model with the EKS auto mode, shared responsibility model with the EKS previously without the auto mode. Okay, all this color part, you are responsible. The like the black and like this part is maintained by the AWS. Okay, and in the like in case of EKS auto mode, in case of EKS auto mode, the part which I have highlighted, this is managed by the AWS people. That means life cycle, instances life cycle, patching, monitoring, health and repair. Okay, all those things you can see, health and repair, patching, operating system, and security features, everything. Okay, compute scaling, that means scaling of the EKS cluster is, everything is maintained by the AWS EKS, and that is automated. Okay, but if you compare that with EKS previously, you are responsible for it. Okay, you can see that here, you are responsible for it in case of normal EKS previously. That's what you need to understand from the point. But in case of EKS auto mode, these things are responsibility of the AWS. But in case of normal EKS without the auto mode, you are responsible to patch, monitor your nodes, life cycle of the nodes, scale your nodes, and repair your nodes with the security patches. Everything you are responsible for that. This diagram which I'm displaying on the screen will help you to understand better. Okay, when we compare EKS previously and EKS with auto mode, guys. Okay, that's what you need to understand from the point. Okay, so let me take the question. Yes, it's automated. My question is how deploying an application. Yeah, it's through CI/CD only, Yuvraj. Application side, EK is not, because application is yours, right? The organizations develop the application, and application is not given to you by AWS, right? So application is yours. As application is yours, you are the person who is going to maintain the applications in the application perspective. That's what it is there. You can see that here. Application containers, availability of the application, okay, and security of the application and monitoring of your application is your responsibility. That is highlighted. You can see that here. In case of EKS auto mode as well, and in case of EKS normal EKS as well. Okay, in both the cases, you are responsible with respect to the application. Actually, that's what you need to understand from the point, guys. Okay, now that's a diagram I would like to present. Okay, so yes, it's a brand new feature, Venkatesh, that is given to us by AWS recently. Okay, so just for your information, we are starting a course on Docker and Kubernetes, uh 7:30 a.m. morning IST timings actually. If anyone are interested on Docker and Kubernetes, I will be the instructor, guys. And if there are lots and lots of stuff that we are going to discuss there, there are 8 different projects and 8 different scenarios, real-time scenarios, and the concepts, and there is lots and lots of stuff that we are going to discuss there. And the sessions, like we are going to spend 45 to 55 days only on Docker and Kubernetes. That means just understand how much depth we are going into Docker and Kubernetes. uh, if anyone are interested, you can contact our admin. She is there in our chat as well. Her name is Janaki, and she is the responsible for, like, she is the admin for our batch. So just you can contact her, and you can Yeah, you can, if you are interested, you can join that as well. So that's what it is. Okay. So yes, ingress is also there. Ingress is used in the Kubernetes. There are lots of ingress controllers. Yes, ingress is used in Kubernetes. Yeah. Okay. Let's move to the EKS now. Okay. Now let's just refresh whether the cluster got created. But you can see, you need to understand EKS cluster creation just takes some time, guys. Uh, Actually, that's what you need to understand. Yeah, Helm chart is also there. Helm chart is also there. Now let me just go through the projects actually before creating this. Like, as it takes some time, I hope we got some time to move to the project that we are going to discuss as part of our course. Okay, if you see the projects that we are going to see, so there's a first project with Docker, and there is a lot of stuff that need to be included here. The actual diagram, like as an overall diagram, I have put this one, but there is a lot of things that will be included in when drawing the project. I'm going to draw this again, and this is a project number 2 with which deals with the deployments in AWS EKS cluster, and this is a project number 3 which deals with the security and the networking in AWS EKS, and this is a project number 4 which deals with the Helm, and we are going to understand what is how to deal with the security in Kubernetes using service accounts and EKS, like Kubernetes dashboard, as well as K9s. We are going to use these tools actually. Okay, and Kubernetes dashboard is deprecated as there is a lack of maintainers. There is a new tool that has come into the market in place of Kubernetes dashboard, that is something called Headlamp. Okay, we are also going to deal with that Headlamp, what is Headlamp and all. Okay, that's the next thing. That's the project number 4. And the project number 5, which is going to deal with the logging stack, that is EFK stack, Elasticsearch, Fluentbit, and Kibana. All these are real-time projects, guys. We are like what I have experienced, what I'm experiencing currently in my company. The same thing we are going to discuss actually, because so that you are going to get the real-time experience. That's a project number 5. And the project number 6 is mainly going to deal with the monitoring of your EKS cluster and alerting. Actually, suppose there is an application down within your EKS cluster, and how to get an alert to your Slack channel saying that your application is down and you need to go and fix it. Okay, so that's kind of alerting also we are going to set up, and we are also going to understand what is instrumentation. Multiple concepts are going to be coming. The service discovery, we are going to understand what is instrumentation. We are going to understand how to instrument your application. You are going to understand so lots of stuff. We are going to understand how to create a Grafana dashboards manually from the console. We are going to understand actually. So generally we just take the code and import that dashboard, but we are not going to do that. We are going to create it manually from the console. How to do that, all those things we are going to understand very clearly as part of this project number 6, which is monitoring of your Kubernetes cluster with uh, Prometheus, Grafana, and Alert Manager. Okay, that's the project number 6, guys. And the project number 7 is going to be the Argo series. In the Argo series, Argo series is one of the tool which performs the continuous deployments, and everything will be automated in Argo series, guys. Just it's very. I cannot say everything as of now, but yeah, in our actual classes, definitely we are going to deal with everything. Very important and very great example we are going to see. Actually, that's what it is. The next number, project number 8, which is going to deal with the Jenkins CI/CD pipeline with with like once you do this CI/CD pipeline, guys. Okay, once you do this CI/CD pipeline, you will be in a level 8. Once the developer push his code to the GitHub repository, until the deployment of that code to the Kubernetes cluster, whatever the things that are manual things are there, everything is going to be automated using this CI/CD pipeline. These are all the projects that we are going to see. 8 different projects that we are going to see as part of our normal course, that is uh, AWS EKS. Okay. Yes, performance metrics is also there. EKS add-ons upgrade. Yeah, everything is going to be taken care by EKS auto, like EKS add-on auto mode. Yeah, auto, like add-ons means it's plugins, right? So normal plugins you need to, if you are adding some normal plugins, extra plugins, that is going to be taken care by us, but not like some of the plugins are there, like something called VPC CNI plugin, metric server plugin. These are the plugins that are taken care by EKS auto mode only. But some plugins which you have installed by which are not given to you by default, then that is maintained by you. Okay, that's what you need to understand. So there's a link that is pasted for our normal batch in the chat, that is by Janaki. You can just take that, and you just come on, you can just take that, and if you are interested, you can join with me there. Okay, and let's deal with now other things. Let's see whether our cluster got created. Just let me refresh. Yeah, you can see that here our cluster got created, guys. Our cluster got created, and initially it got created with some two nodes, because while creating the cluster, some of the applications will be automatically deployed to the cluster for managing the cluster actually. So that applications need to have some nodes. You can see that here these are the two nodes that got created. You can see that very clearly as part of this. Now EKS, or let's deal with EKS node viewer. Okay, now let's me go to terminal, and just let me clear the screen, and now you can see EKS space hyphen node hyphen VIEWER, EKS node viewer. If you click on enter, come on, now it is not working because we need to connect to the EKS cluster first. How we can connect to the EKS cluster? How we can connect to the EKS cluster? What's the cluster name? Prod hyphen prod. What is the region that is there? In which region we have created EKS cluster? It is a region of Ohio, right? US East 2, right? So now you need to connect to that EKS cluster. That is why it is not working. How you connect? AWS EKS update hyphen cube config hyphen name is equal to prod hyphen prod. Before connecting, you need to do some configuration, guys. So I cannot show everything here because it's a webinar session. Everything will be taught in our normal session, but yeah, how this is how we can connect after doing that configuration actually. Hyphen region, I mean you need to configure your local environment to connect to the AWS environment actually. That's what you need to, that's what the configuration that you need to do. US, some of you people might be knowing that. Okay, East 2. Okay, I'm just connected to the EKS cluster. You can see that here I've connected to the EKS cluster. Now you have a tool called EKS node hyphen VIEWER, EKS node viewer. If you click on enter, now you will be listed with two nodes. You can see that here these are the two nodes that are available in the cluster, and there are two pods that are available in the cluster. Out of two pods, two are running. Two pods, two bound means two pods are available in the cluster. Out of the two pods, two pods are running actually, and the node CPU utilization is 6%. If you see that here, 6% of CPU utilization, one pod on each node that got deployed. You can see that here, and these nodes are on-demand servers, and you can see that here what type of the EC2 machines that got launched, and the price of that EC2 machines will also be shown here, and per hour price will also be shown, per month price will also be shown. You can see that here. That's what you need to understand from the point. And these are ready, these are in the ready state. That's what you need to understand from the point. Now what we are going to do, we are going to deploy lots and lots of applications to the Kubernetes cluster, this EKS cluster, guys. This EKS cluster, we are going to deploy lots and lots of applications. Let's see whether when we are deploying the application, let's see these nodes. As of now, there are two nodes, two servers in the cluster. Let's see whether these servers are getting scaled automatically or not. For that, I am going to use something called open telemetry applications. Okay, just these are the open telemetry applications that we have, and you can deploy that as a Helm chart. These are the two commands with which you can deploy these applications to the cluster. Just copy this command. Okay, I've already executed the first command and just copying the second one. Okay, just go there to the terminal, and I'm just opening the new terminal, guys, and just I'm executing this particular command, and that will deploy all the stuff to the Kubernetes cluster. Multiple applications will be deployed. Now let it deploy, guys. As of now, we have only two nodes. You can see that there. Okay, we have only two nodes, guys. You see, there are two nodes only, but you can see that here my application is going to be deployed soon. Just it will take time. Yeah, you can see that here my application got deployed. And now if you see the pods got deployed, kubectl get pods -a. If you click on enter, so it will show you the pods that got deployed. These are the lots of pods that got deployed. All the pods are in pending state. You can see that here. Now let me go to this EKS node viewer tool. You can see that here automatically a new node got added. Okay, because there are 26 pods that are being in pending state. Every pod should be in the running state. EKS auto mode feature automatically created the node, and existing nodes are see existing nodes uh, it did not use, because this many pods cannot run. 27 pods are there. All those pods cannot run on the existing nodes. It requires a new node to run these 27 pods, 27 applications, right? In order to run these 27 applications, EKS requires a new node. That is why it created the new node, and it is going to deploy this 27 pods on that particular new node, guys. You can see that here 73% of the CPU is being utilized, and you need of worrying about what type of instance is going to be created. It is going to be automatically taken care by the EKS auto mode. You can see that here it has created m5 dot like m5a dot large node based on the number of applications that you are deployed to the Kubernetes cluster. And the price for that particular uh, 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 m5a dot large is this one, and it is in the ready state now. And the price of our EKS three nodes got increased, and $181 per month. You can see that very clearly there as part of that thing actually. Okay, yes, Joseph, you're right, Kishore. Even if the load is more, it is going to create. Whenever the load is more, the CPU utilization will be more. Like whenever the CPU utilization is more, then automatically EKS auto mode is going to create a new node. Okay, like the similar way. If you see all the 27 pods, like it should be, they will be soon be running, because they need to download some Docker images. All those stuff will be there. So they will take some 4 minutes of time, I think so. Like some time. You can see that here previously they are in the pending state, because there is no node in the Kubernetes cluster to run these applications. And EKS auto mode automatically provisioned the node, created the node, and this pods are going to be deployed on this node. That is why they went from pending state to container creating state. Okay, that's what you need to understand from the point. They are going to take some time to be coming into running state. Actually, we need to wait for that. Okay, just we'll be waiting for that. Anyone have any questions, guys? Let's wait for that to be coming into running state. It's a great feature. So all such kind of things like EKS auto mode, like it's a great feature, guys. Like such kind of concepts we are going to discuss as part of our course. Actually, that's what you need to understand. Yeah. You can see that here previously there are 27 pending. Now there are only 20, 24 pending, because few pods are running. Okay, we'll just get the pods one more time. You can see that here this pod is running, and this pod is also running. Like that, it will take some time to run, to be coming into running state. Now you can see that here 22 pods are pending. Now, yeah, other two pods are also came to running state. Yeah, you can see that here 18, 17 pending. Now they are getting decreased, 16 pending. All are getting into running state. And overall cluster CPU utilization percentage on an average is this much, 28.1%. 7 pending now. 11, sorry, 11 pending. Yes, Joseph, because you are using some advanced feature of AWS EKS, that is auto mode. So there will be some price difference. And it is going to decrease your price as well. That also you need to understand, because your nodes are getting provision whenever they are required only. Okay, 6 are pending. Let me get the pods, and you can see that here most of them are in the running state and few of them are in the container creating. Let's wait for that. Yeah, 6 are pending. Okay, like that. Whenever they are required, only the node will be provisioned. Now let's delete all these pods. What will happen? This node should be whichever provision that need to be removed from the cluster, right? That should happen automatically. That is a that's also one of the feature of auto mode, because whenever the applications are not there in the Kubernetes cluster, whenever the application CPU utilization is very less, then automatically node should be removed, right? That's what also you need to understand. So that is also going to be happening with EKS auto mode, guys. Let me go here, and if you get the, like, let me delete this applications. How to delete is using Helm, guys. Okay, just I'm deleting it. You might be knowing before, but yeah, if you are not knowing, yeah, definitely we are going to discuss Helm list and Helm related things in the classes. Okay, let me delete this particular release. Helm delete, and the release name, just we'll click on enter. Yeah, Yuvraj, that those things are handled by the admin. You can please contact her. Admin, Janaki, can you please share your number here so that people are going to contact you? Now you can see my applications got deleted. Okay, they are terminating, and the you can see that here node CPU utilization is 0% now. This node should be gone. Still, it is in the ready state. It should be going into terminating state soon. Janaki, can you please share the number? Just let's wait for this to be going to terminating state. No, we are not going to use any normal YAML files, guys. Most of the people won't use normal YAML. Okay, you can see that here it is went into the deleting state. The node is getting deleting. You no need of worrying about anything. Everything will be taken care by auto mode only. Okay, creation whenever it is needed, deletion when it is not needed. Everything is going to maintain, upgrade, security patches, all those things which I've already displayed on the diagram, right? All these things are going to monitoring and all those things, life cycle, and everything is maintained by the auto mode only. You can see that it is went to deleting state now, because there are no applications, and there, as there are no applications, EKS decided that the node is not required in the cluster, so that is why it is deleting the node. Yeah, we have like we need to monitor, Sunil, actually about that. So what is happening in EKS auto mode, since the cost might shoot up? Yeah, you need to monitor about that. Like it might be through, if you're talking about the applications, what might be happening, you need to just monitor through the what is that? Prometheus or the Grafana, whatever what we are happening with, what is happening with the applications when we deal with the EKS auto mode. Now, if you are talking about the cost, you need to deal with some management, AWS cost billing and cost management dashboard. Okay, so then also you will be able to understanding about that. Okay, so you need to audit about that. Yes, you're right. Okay, you can see that here the node got automatically deleted, guys. Okay, so that's the importance of EKS auto mode. Okay, so it's very great feature that the AWS has released. Even though, as if we are using the EKS auto mode, they are going to charge a bit for us. Even though that is been there, still they are our cost management, our cost will be very less, because whenever the server is required, only server will be launched. All the time server will not be there in the cluster. Okay, that's what the reason. Okay, it is Prasad. It is going to share by our admin. Where is our admin? Come on, Janaki, are you there? One second. Did I have her number? One second. Let me just check whether I have her number or not. Don't think so. I have. I don't have her number actually. I might have shared, but yeah. Anyone, okay, you can contact any admin. So just they will redirect you to the Janaki, no issues actually. So that's fine. Okay. Or else you can join in this particular I think she has shared some community link, huh? Yeah, here is a community link. You can join it here. Uh, so that you are going to connect with her directly. You can join in that WhatsApp community. You can click on that and join there. Yeah. So you can be very easily able to connect with her. She's going to share everything there. Okay. Okay. I hope the session was interesting, guys. Anyone have any questions from your side? Are we clear for today's session, guys? Are we clear? Yeah. What's your question? Can you ask in chat, guys? Venkat? Are we good for the session? No, see, charges will not be applied because, uh, as there is no node, Prasad, as there is no node, okay, the charges will not be there. Yeah, Janaki, can you please share your number? Yeah, can you please share your number in the chat as you have come so that people can contact you for our course? S- Yeah. Sir, end-to-end mismanage AWS EKS or we need to use EC2 instance. It's managed EKS, not easy to instance directly. That's a number, guys. Janaki has shared her number. You can just contact her through that particular number for our course. Okay. There's a great like there is a lot of stuff that we are going to move through. Everything is going to be deal with practicals and the real time because I know what is going to be used in the real time that we are using daily, and we will be dealing with that only. Okay. Yeah, in our sessions you can, Yuvraj. Not now. I don't have permissions. But in our sessions I will be having that. So okay, thanks guys, thanks everyone, thanks for joining with me. I will meet you in our sessions. Okay, thank you guys, bye. Note the